All right, there we go. All right, exponential functions. All right, so first part, let's talk about our exponential function. It is in the form of f of x equals c over a to the x. All right. A is a positive real number. It cannot be 1, and it has to be greater than 0. Okay? A is the base, and in real life scenarios, it's considered the growth factor. And C is your coefficient that equals your initial value in your real life scenarios. Okie dokie. All right, so go back in your memory banks to chapter 2, maybe? When we were doing parent functions. And we had all the graphs. Anybody remember what the graph of the exponential looks like? Yeah, it looks like the little... All right, so if we have where a is greater than 1, so my example is going to be f of x is equal to... Cam, give me any number greater than 1. 8 to the x. Okay. Then my graph's going to look like that. Do we remember that?
A little bit.
Okay. All right. So, what's the domain? Looking at the graph, what's the domain? Because this is going to come close to the x-axis, but it's never going to touch it. So it's going to keep going on to negative infinity. So it's going to be, your domain is going to be all reals. Okay. What about my range? What am I going to have for a range? Because ranges are y values. Do I have any y values down here? Oh, I don't. I don't have, my graph doesn't go down there. So, and it never touches 0, so that means it has to be that x is greater than 0. Or we could write it as from 0 to infinity. Either one works. How about x-intercepts? Look at the graph. Do we have any x-intercepts? Nope. There is none. But what about our y-intercepts? Can you see that? What is that point right there?
1 point something.
Actually, it's just 0, 1. Good call. Okay. All right, go back in your memory banks to chapter 4, maybe? What are asymptotes?
It's like the line that they can't touch.
It's the line they can't touch. Perfect. All right, so, because remember we'd have like an asymptote here and an asymptote here. So the graph would come and then be like, because I can't cross it. Or it would come from here and go, oh, I can't cross it. Remember all those? All right. Do we have, or does the exponential have an asymptote? Where? Yes, I agree, it's yes, but where at? No, because over to, this is going to still increase up. But what's happening here? Fact-
On it.
Oh,
So the
so-
x-axis. the horizontal.
Yeah, let's put it where it's a little bit not quite so steep. Yeah, it's going to be our x-axis. As it comes down, it's coming down. It's never ever going to touch the x-axis. Okay, so goes like that. And so remember, asymptotes are always as an equation. And so we'd have y equals 0. The function is increasing. Now, who can tell me how you tell if it's a one-to-one function? What is that?
Horizontal.
Okay, horizontal is where it tells if it's a one-to-one. What does the vertical do? What's a vertical line test tell you, teach you, or tell you? That one's just whether it's a function. Horizontal, going horizontally, tells you if it's one-to-one. And are we one-to-one? Yes, it never hits.
Yeah.
Okay. And our graph is smooth and continuous. Always, always, always contains these 3 points. Okay, -1 over 1 over a, 0, 1, and 1a. So for my function where I have f of x is equal to 8 to the x power, it would be -1, 1 over 8, 0, 1, and 1, 8. Good? All right, this time let's look at if a is less than 1. So somebody pick a new base that's less than 1.
-3.
It has to be a positive real number. It has to be great positive. So between 0 and 1. So that would be 1/10. All right, so f of x is equal to 1/10 x. All right, let's look at what that graph looks like. 1/10 x. What's the difference? It's coming down this time. All right, so what's my domain going to be? Yeah, it's going to be the same. It's going to be all reals. And what about my range? Is it going to be the same? Yeah. X is greater than 0. Do I have any y-intercept? No. So that one stays. That's the same. Or I mean x-intercept. What about my y-intercept? That one's going to stay the same. Do I still have the asymptote? Sure do. Still have y-axis, so it stays the same. Am I increasing? No, this one is where it's different. I'm decreasing, but it's still 1-to-1. It's still smooth and continuous, and it still is going to hit all 3 of these points. I'm sorry. How do you find them?
How do you know, like,
because the parent function that just, it will always go through that. If you stop to think about, if I have, well, in fact, you know what? I'll tell you what, hold that thought till we do the exponent rules, and then I'm going to show you. All right? How's that sound? So let's do that. Let's talk about the exponent rules. The laws of the exponents. These are all the rules. We're going to go over them again, but there's one mistake. Who can find my mistake? I have a typo. No, last one's good. Which one? I'm talking about in here.
That one?
Nope, that one's good.
I don't know why that word sounded so funky.
No. All right. It's this one. If you have the same base and you're just multiplying the same base, you add the exponents. Okay. If you're doing a power to a power, then you multiply. And if the exponents are the same, you can regroup it. It's kind of like distributing. Do these ring bells? Huh?
I hit my elbow on the table, so you're recording my hand. Probably.
Oh, that's all good. I don't think they heard it because I didn't hear it. It's all good. Okay, so if you have a negative exponent, remember you can rewrite it by writing it as a fraction. And there, Mac, is where we get the how do they come up with that point? Because if my function is a to the x, okay, and I have x as -1, that's like saying a to the -1, and this rule tells me that I can rewrite it as a fraction. Does that make sense? Okay. All right, and then any number or 1 raised to any exponent will always be 1, and 0 exponent always equals a value of 1. Always, always, always. Do we remember all that part? Yes, kind of. All right. So, when we have two exponential expressions, if you have the same base, then their exponents are equal. And so if I have 3 to the x and 3 to the 6, since my base is the same, that means that x is equal to 6. All right. And our last example is just talking about finding a function modeled by a table. So think about all the different functions that we've done this year. We're doing exponential now. Okay. What's another? What's the very basic linear function that you guys did in Algebra 1? linear equations. Absolutely. Okay. And then what other kinds are there? We did parabolas of graph. What are they called? Or quadratics. Okay. All right. So we want to figure out what function we have if they're modeled by this table. Okay. So basically, what you want to look at or compare, what's the difference between linear and exponential? Yeah, that's it. The slope of the line, right? And so if you look at their slope, it'll tell you which function it is. So if we compare our x's, the difference between all of those is 1. So all I have to really do is look at my y values. Would you agree with that? Okay, so what's the difference between 1/4 and 1/2? 1/4, right? And what's the difference between 1/2 and 1? 1/2. So there alone, I know it's not linear because I've got something different, right? The difference between 1 and 2 is 1, and the difference between 2 and 4 is going to be 2. Right? So I know it's not linear, and I see a pattern. So if I rewrite this in terms of my x, I could say, hey, this is like 1/2 squared. Would you agree with that? Which is the same as saying because 2 squared gives me 4. And like this would be like saying 1/2 to the first, which I can then rewrite as 2 to the -1. Does that make sense? And 1, if I'm trying to find out, I can rewrite it as 2 to the 0 power, because anything raised to the 0 is going to give me 1. And this one I could rewrite as 2 to the first, and this one I can rewrite as 2 to the second. So I'm consistent all the way down. I go down with my x values. So what's my base going to be to write my function? 2. Does that make sense? All right, then let's look at the next one. Again, I'm going just once, so that's good. What's my difference between those two? 2. I added 2, right? What's the difference between -1 and 1? I added 2. So what kind of function do I have there? It's linear, because I have the exact same slope. So I could say f of x equals 2x. Actually, that one's going to be +1. How would I know where my +1 came from?
Because isn't the y-intercept next to 0, 1, so that'd be +1 because that's the y-intercept at 0.
Because that's my y-intercept there, and I took it off the table. Good? All right, the first 12 Math Excels are like tables like these, like I said, vocab words, stuff like that. After tomorrow and Wednesday, there's 13 through 25 solving equations. I'll do Friday at 3. But like I said, we're gonna have decent amount of class time to work on it. Okay? Good? Questions? Concerns?